Go ahead.
Hi, we are the team Thermosensor campus, and I'm the leader.
I'm Zing Tao, purchasing and manager.
I'm Zhu. I'm doing record and data analysis, record management.
I'm our China safety officer.
Doctor, addition. And thermocouple is an electrical device used to detect the temperature changing, and basically the voltage change will be generated from the junction of the thermocouples. And thermocouples are being widely used in many fields, and therefore, for our goal is to determine how the time response will change, and regarding to the changing of the size of the thermocouples, and also for the different materials. For our team goal, we're gonna build a nano thermocouple sensor and connect to the microprocessor and the amplifier. For the time response, we should be reduced from 1.6 seconds to 103 seconds. And after that, we're gonna apply the wireless device to make it into a product. And for the last quarter, we researched about the thermocouples and processing most of the components. And we designed and built a circuit and using ice pack and boiling water to calibrate the thermocouples. And for this quarter, we trimmed the thermocouple tips into different lenses and measuring the time response. And later on, we're gonna break down the thermocouple tips and research about different materials. For next quarter, we're gonna test different types of thermocouples with different types of materials. This is for organization, and we have 5 people in this team. And two of us are gonna searching Arduino codes, debugging, and analyzing data from the experiments. And 2 of our team members researching, designing the schematics and assist experiments. And this is our timeline. We are at the reducing the time response for the thermocouples by cutting down the tips into different lengths. And we're gonna break down the thermocouples later on and research about the different materials. And maybe we try graphene. And for the future, we're gonna test the different materials and different sizes of the thermocouples and compare the results. And we're gonna build a thermocouple by our own. And finally, we're gonna apply the wireless device and make it into product. So thermocouple is it's the voltage change in the direct relationship to the temperature changing for the thermocouples. There are 5 points for the engineering principles. Keeping simple, testability, stability, integrity, and external integration. For our testing progress, we put the thermocouple into the ice water or boiling water. Then we connect to the schematics to the Arduino and to the computer, and then we remove the thermocouple when the temperature is stable, and we do the multiple runs, collect data, and sketch the temperature versus time graph. Then we get the results, and then we compare. This is for the progress we have right now, and we upgraded the circuits from the last quarter, and we tightened the cord and using the jump cables instead of the breadboard. And we managed to shorten the time response from 1.6 seconds to the 1.08 seconds. But somehow the noise is a lot more than the previous setup. This is the graph for the before the improvement, and this is graph for after the improvement. The noise is a little bit more.
So after the research, I find out that all type of type K thermocouples are made of nickel, chrome, or nickel aluminum. Because it's not easy for us to build a brand new thermocouple. So for future testing, we're just gonna replace the wire using different material, try out different combinations, such as copper, aluminum, or carbon nanotube. Just pretty much to see which one give us the best result. If that doesn't turn out to be positive, we're gonna try to apply some graphene coating because it's highly conductive. So and it's already in use in highly sensitive gas sensors. So we're trying to do that next.
So here is what we have already purchased for this project, and then we have already spent around $250 for this project. And then for the feasibility, and the first idea we come up with is we want to try the graphene coating for our sensor. But even if the graphene is available for now, but the amount we need for our sensor is still very small. So there might be some difficulty for having our sensor coated. So that's why we come up with the second option is to switch our sensor to different materials, such as copper, aluminum, silver, nickel, or even possibly we are trying to use the carbon nanotube. And those are material can be easier to find online and be able to get them within days.
So the bigger picture, pretty much what we're trying to do is build a quick and efficient temperature monitor system that can be attached to human body. So we're trying to, what we're trying to do is design like a system can use for a certain group of people, especially for like athlete or infant. I think it's going to be extremely helpful for the infant because they cannot communicate with us. So by using that, I think it's going to help their parents monitor their kids' health.
Thank you.
All right, questions for this group?